Did you know economists in Ho Chi Minh City changed how we think about alerts in critical infrastructure after studying the Madagascan hissing cockroach? You're listening to Wild Engineers, decoding nature's intelligent designs in your coffee break. Let's dive in. Many of us know the story of the boy who cried wolf. Essentially, a young boy seeking attention cries out wolf when there is none. Hearing this, his family runs to his aid. This event repeats so often that one day, when there finally is a real wolf, the villagers hear the boy cry out but tragically assume it is another false alarm, and the boy perishes needlessly. Building systems can experience the same thing. The alert that once mattered starts blending into the background, becoming white noise. A warning light stays on, but no one pays attention. Hi, I'm Melanie Farmer, and today's question is, how does nature prevent critical signals from being ignored over time? Meet the Madagascan hissing cockroach. In the wild, these cockroaches depend on touch, vibration and obstacles again and again for hours. Over millions of years of evolution, the cockroach risked overloading its nervous system with all that sensory input, resulting in a weakening of signals. An issue biologists call habituation. Basically, repeating a signal too often and neurons can adapt to tolerate stimulus that might be meaningful and important. Researchers at the University of Economics, Ho Chi Minh City, studied this exact problem. They noticed something important. The cockroaches deploy two feedback loops running at different speeds, a fast loop that reacts immediately, and a slower loop that watches for long-term change. When responsiveness drops off, the clever system changes the pattern of the signal. Timing varies, intensity shifts, and rest periods are introduced. What the researchers found is that by applying this mechanism, the nervous system stays alert without resulting in burnout. Okay, while not identical to our cockroach, where sensing is both short and long-term at once, one group did apply similar design principles as follows. At Maitland Hospital in Australia, the team redesigned nurse call alarms so that most alerts stayed silent at first and went directly to the assigned nurse's smartphone, then escalated to a backup nurse if unattended, while truly high-priority events still triggered immediate audible tones. The mechanism applied one signal for immediate targeted attention and a different escalated signal for broader action instead of blasting the same sound constantly. In a 12-month study across 6 inpatient units there, the system handled more than 262,000 calls and alarms, 84.8% of which remained silent until escalated, and the hospital reported an overall reduction of 1,940 hours of alarm noise, helping preserve audibility for the alarms that really mattered. So we started by asking, how does nature prevent critical signals from being ignored over time? Nature's strategy is adaptive signalling across timescales. The mechanism including fast feedback for immediate response requirements, slow feedback for long-term drift, and pattern variation and escalation to maintain attention. If your building or human systems are working well on paper but failing in practice, maybe you are at risk of habituation. Could you consider something as simple as making your system stay interesting by varying the signalling cadence or method? That's wild engineering. Thanks for listening, stay wild, and see you next time. That's it for this episode of Wild Engineers. If you're inspired to apply nature's intelligence in your own work, check the show notes for more detail. If you know someone who could benefit from this episode, please share and help us redesign our world inspired by nature.